Hello, everyone. I hope we are live now. So here we are, Tim Ellison and me, Tanya Obradovic, and we're kicking off yet another JakartaOne live stream. We're extremely happy to see everyone. We have almost 350 people. Everyone. I hope we are live now. So here we are, Tim Ellison and me, Tanya Obradovic, and we're kicking. Can you hear me? I heard some echo on my end. All good? Okay, fantastic. Just want to make sure because I'm kind of suddenly got confused because I got the delay of a few seconds and then my voice again. So anyways, welcome. I just wanted to kind of give everyone a little bit of a heads up in terms of what we're preparing before Tim takes over and starts talking about the cloud native runtimes. So basically, you are familiar that we're trying to run the live streams as much as possible, particularly now in the new era that we're approaching, which is pandemic situation, and most of us will be welcoming communication online. So heads up about the other JakartaOne live streams. So one is being prepared for September 2020. And it is going to be our annual big JakartaOne live stream. If you remember, we had one last year. And then before that, we are working on preparing JakartaOne Livestream Brazil. So this is going to be very similar to the one that we prepared for the Japan, and it was in Japanese. So the Brazil one will be in Portuguese, and please watch out for that. Here are the links, but I will share that with you later as well and on the social media. So not to take too much from Tim's time, I would like to invite Tim, and so he can tell us about the runtimes. Is it evolution or revolution? So Tim, if you want to take it over.
Perfect. Thank you, Tanya. Let me just go into display mode here now, so hopefully everyone can see these charts. I just wanted to echo Tanya's welcome. You know, this is really extraordinary times for everybody. So the fact that we've got such a good number of people here for the start of the JakartaOne live stream, I think is really encouraging. So thank you for joining. This is a really exciting time in cloud native. It's exactly the right moment to be discussing these sorts of new technologies, because technology is changing very rapidly. We're all learning how to adapt as we work from home or other places and eventually get back into our business settings. But business is changing, and the technology will be changing around us to address that. So what I thought I'd do today is address some of the sort of non-technical challenges around cloud native runtimes and cloud native Java in particular. There are some great talks coming later on in the conference, in the virtual conference that we're at today, that will go into some of the technical details and educate you about specific technologies. But I wanted to take a little bit step back as we open up the virtual conference and put this in a setting as to why we care so much about it. So the first question which came to my mind as we started this topic is what exactly we mean by cloud native for Java. And cloud native for Java, in my opinion, relates to a number of business challenges and opportunities. It's fun technology, but at the bottom of that technology, we have to remember that we're addressing real business challenges. And the first one that I would call out is ensuring that the technology that we're building is really a cost-effective way of delivering services to our end users. cloud brings with it a whole new model of paying for the compute and the services on which that technology depends. And so one of the ways we want to adapt our runtimes and Java specifically is to take advantage of that new cost model and ensure that the businesses that we build are very effective in the money that they spend to deliver our services. It also means scalability. So again, when the business demands change and change so rapidly, we can see a surge or a diminishing of demand upon the business in different areas. Again, we've seen this absolutely in terms of the pandemic in which we're all living at the moment. There are certain aspects of our society at the moment which are putting large strains on the computer systems that we built years ago. They have to be able to scale up, and being part of the cloud gives us that ability to scale. But likewise, where the demand has dropped off dramatically, we need to be able to scale it back and not be spending money on infrastructure and resources where they're not required for the moment to support our business. And thirdly, I would claim that being cloud native is all about your ability to adapt to those changes in the business environment. So that's not only changing based on the demand of our existing users, but also changing based upon the disruption of other people who come into the area of industry in which we operate. Having a large established business is no longer an assurance that it used to be. New nimble companies will come along into the market, can quickly establish a new and innovative idea or a very convenient way of operating that hasn't been done before, that can't be provided by these large companies. And so that's why everybody has to become adaptable and able to change very quickly. So with these kind of business drivers in mind, the question is, why do we need to modernize our existing applications? And we've kind of spoken a little bit about this at the moment, but if we look at the technology around it, our ability to modernize, to adapt to those business drivers can be somewhat limited by the technology and the architectures that we currently have. So it could be the case that the architecture that we've built these large systems around has got some limitations about the ability to add new features very quickly and deliver them. But it's also the way in which we organize our teams within the organization, which also has got some inherent process to it. And perhaps that process also has some limitations in our ability to deliver. So we're not only talking about the technical changes of moving to a cloud native runtime, but also the organizational changes that will be required. And I think those two things really do have to go hand in hand. It could be that we have got systems which are becoming too expensive to maintain. Over a period of time, the technology that we've become used to will go into a maintenance mode, and we'll be either paying within the company or paying externally to maintain that technology over a long period of time. Skills become more difficult to find. The technology could be older technology, which is difficult to update to address the newer features. And so, we may have dependencies on long-running support contracts or teams within the organization, which have to be updated to ensure that the business remains relevant and viable for the future. But even if you maintain your architecture and you maintain your team structure, the world is changing around us. And so the platforms on which we are running our applications are changing. And so our applications have to deal with that. They may be becoming highly virtualized. We may be moving into Kubernetes-based containers, and the applications that we've got don't suit that environment. They're not optimized for that level of virtualization. And so if we don't modify and change the systems that we've got, then the performance will suffer, or there will be other ways in which we are disadvantaged by it. So it comes back to kind of two schools of thought as to how we can address this. these business challenges. If we look at the two sort of extremes, one extreme would be to say, well, we're going to rewrite our existing systems based upon the new technology that we've got. Now, obviously, that's a very high-risk strategy because it's going to be highly disruptive to the business whilst we do that replacement. And it also requires us to build new skills very rapidly. It may be okay for a smaller company, a startup, to decide to throw away what they had developed as a prototype and to rewrite in the latest type of technology. But we typically don't have that privilege in established companies, which can do that. We could make a decision that we're going to just write new systems using these new frameworks and technologies and integrate them into the existing systems. That, again, is going to require very careful planning, not only in the technology that we use, but in the way that we operate as teams as well. At the other end of the spectrum, we can just claim that we're going to incrementally tweak the systems that we've got and try and add in the agility and the changes to our systems that exist today. That kind of tends to build up very large bodies of spaghetti code, complexity for the ability to make any changes in the future. And we kind of really there are deferring and building up a technical debt of any revolutionary type of change that we need to be able to enact if someone was to come along and disrupt our area of business. So we need to mitigate both the technical and the business side in the enterprise. And as I've mentioned earlier, I think that a key part of this is ensuring that the organization within the business agrees where they fall in this spectrum. There's no value in one part of the company choosing to rewrite systems from scratch whilst other people are trying to incrementally change systems, because it requires a unified approach where development teams, operational teams, management teams, and even the funding across those teams reflects the way the whole company is changing to be cloud-oriented and cloud-focused. So when we're talking about modernizing existing systems, we're talking about taking existing technology and adapting it to modern business and organizational changes. And our existing systems, which we often tend to call legacy systems, are the ones that got us where we are today. That's our investment. That's where our skills lie. So we're not going to throw that away. That's not, legacy is not the dirty word. Java systems are still powering businesses of the world very successfully, and we want to enhance those. So Java is the correct technology to take with us as we go forward into the future. And even if you are not interested in taking that with you, I would argue that you have deep dependencies on large number of third-party code, which itself is not going to be going through that modernization. So we'll always be in that sort of hybrid stack, whether it's the relational databases, third-party code libraries to achieve particular functions, integration with your CRM systems, etc. It's going to require that kind of blended adaptation of existing technology as you move forward into a cloud-native world. So the goal is to complete your modernization with a maintainable and extensible system that you can deploy and manage at the pace that the business's current and future needs within the capability of the skills that we've got within the business. So our ability to modernize depends upon the history and makeup of the business organization, and the rate and pace at which we can make those changes it really is dictated by the rate and pace at which we can change our organizations. Now, if we turn to Java specifically, Java is a key enterprise skill. As I mentioned earlier, this is the place where we've got our investment. And so there is a really strong motivation to take Java with us on this journey as we move to cloud modernization. There are multiple dimensions in which we can look at Java's role in application modernization. We've got modifications to the runtime implementation itself. So that is its ability to adapt to changes in those architectures that I spoke about earlier, and also the environment. So ensuring that the Java implementation is aware of containers, or that the JIT is available as a service to share across multiple deployments. Java changes by providing us with new APIs and capabilities, so that developers have got new technology to draw upon as they build in these new architectures. So, for example, MicroProfile and Quarkus. I know there are talks later today from Roberto, who's going to talk a little bit more about those specifically. They're offering new features and functions which are going to be available to Java developers, which are relevant in that cloud environment. And there are tools available that can have a look at an existing system and tell you the suitability of moving it into that cloud environment within those new APIs, and give you some positive feedback about those as well. And then as we modernize Java, again, it's all about the community diversity and the different views that people bring to the table to show the sorts of technology that is going to be required in a cloud environment. And so, here at Eclipse, we've got a prime example of the community coming together and sharing their experience and their desires for how this is going to evolve in the future. Again, I know that Will is talking next, and he's going to talk about all of the movements of Jakarta to Eclipse and the success that the community has had in receiving that and starting to take that forward to its next level in its evolution. So if we look at the modernization journey for Java, I'd like to kind of break it down into 3 different types. We've got just what I call the lift and shift to cloud. That's taking a large monolithic application and moving it onto the cloud platform. The next layer may be to start to run applications in containers and deploying containers within the cloud environment. And thirdly, and somewhat simplistically, building with architectures which are cloud oriented. So whether it's macro services or microservices, whether you break it down into individual functions or a reactive platform, something like that. But really fundamentally changing the architecture of the application to address the cloud platform that you're living in. So looking at the lift and shift as an example, that has its advantages, because you've now shifted a lot of the capital expenditure that you would have in the business to run as a platform service. You're still taking the existing applications, but you're changing the cost structure on which those applications can run. The operations team will still be managing those systems. They continue being the experts to ensure that the cloud platform has been sized correctly to run the applications. They're doing the administration, the execution, the debugging, and all those sorts of activities. Even if you just do that simple lift and shift, you'll get some advantages of Java realizing that it's running in the cloud, so that you can really deliver on those cost advantages. So having a cloud-aware Java is certainly relevant even in this type of model. But it has a relatively low impact on your ability to deliver that business value. You're reducing your costs, but you're not getting the full benefit of the ability to deliver updates to your application very quickly. And that's the sorts of things which will come with different styles of migration to cloud. So I spoke about containerization of applications as well. This is going to have a bigger impact on the organization. So in these cases, as you containerize applications to deliver into a cloud environment, the developers need to start to learn about the additional constraints of running in containers, such as immutability. The development team will be taking on more responsibilities that they would typically have deferred to the operations team. So, for example, controlling the time on which software is updated within containers, which may previously have been part of the operational scope, may well now be deferred to developers to choose, as they just deliver a container out into the environment, which means that the operations team become responsible for delivering a standardized platform provider for running containers. So, this is likely to be a Kubernetes in today's world, but they're also running the CI and the CD pipelines. They're doing the incident analysis, and they're providing all of this structure around the ability to ship a containerized application in the cloud. And that gives you not only an impact to development and to ops, but you're now starting to get into this whole joint responsibility through a DevOps team of taking on the infrastructure responsibilities. That's the logging and the monitoring, managing secrets that are flowing through the cloud system, and security, etc. And the DevOps team will typically be doing infrastructure as code. So here we're getting into the ability to write code to define the environment through Ansible, through, again, Kubernetes structures that allow for this full level of automation that has a bigger impact on your business now, because the developers are much closer to their ability to update containerized applications and deliver that straight through. And then I mentioned microservices and functions. Again, this is not a kind of a goal per se to be cloud native. This is an architectural style which is suited to the cloud environment. So, I'm not advocating that people go off and completely rewrite existing applications as a bunch of microservices. That may not be appropriate. But if you're in that cloud environment, then having access to the frameworks which allow you to build microservices, functions, and bring containerized applications into the cloud gives you a much broader set of tools on which to address your business challenges. If you're building microservices, it gives you the ability as a DevOps team now to decrease the scope of the releases that you're making. So we've talked about kind of the platform and the environment on which the DevOps team can be developing code and deploying it out into the cloud. By choosing microservices, we have the ability to decrease the scope and so have a much faster turnaround. And this is where we start to get the benefits of the agility and the scalability that I spoke about right at the beginning, which is how we have a very responsive type of business, and we can really deliver and ensure that this technology comes with us and delivers for the business. So I think Java is well placed to deliver on all of these fronts. People will be at different stages in their journey as they move to cloud native, and none of them are any better than any other. That's kind of the message I wanted to get across today, is that while it's trendy to be completely reactive, that just may not be appropriate for the style of application that you have grown up with and been successful with and want to start moving on that journey to cloud native. So, we know that Jakarta runs large amounts of business at the moment, and Jakarta has begun this very exciting journey as it's transitioned to the Eclipse Foundation. It's getting new capabilities, which are going to be very much focused on ensuring it integrates well with the newer technologies in MicroProfile and other areas, which themselves are developing those APIs for very cloud-focused capabilities. We've got things like integrated developer experiences through Che and other projects, which are ensuring that all of this can be hosted in one seamless integration throughout the cloud. And then we have the OpenJ9 runtime itself, which is container aware and cloud aware, so that when you're running your Jakartas, your MicroProfiles, and your other applications in the cloud, you're taking full advantage of that business agility. So the question at sort of the top of this discussion really was around whether cloud native Java is an evolution or a revolution for us. And I'm going to kind of sit on the fence a little bit, but claim it's both. All right, it's both a revolution for the business organization. We need to get into the mindset that this is not business as usual, and it is arguably more difficult to modify the structures within the organization about where the budgets flow, where teams are organized, how things get developed and deployed and then managed over a period of time. Adapting to the new costing models that come in from more things being runtime costs after deployment than they are in the past, where we may have written off some capital expenditure over a few short years. But it's also evolution for the technology that we've got. We're not throwing away Java. We're not rewriting all of our applications in new languages, but we're evolving Java to be aware of this environment and capable of taking the existing technology that we have with us and being just as relevant in cloud native as any other technology which is there. And I think Eclipse is the prime place where that has been well demonstrated, and the community has come together with that as an understanding of where that will take place. So I just wanted to wrap up with a quick thank you for your time. This is a very fast-changing area. I think everyone's doing the right thing by joining a conference like this, keeping yourself educated and up to date on what the latest technologies are. There are some really interesting talks coming along from the experts in their areas who will be able to tell you about all of the technical detail. I wanted to start off by just setting it in that context, encouraging you to stay for as long as you can today and enjoy the technical talks and the remainder of the conference. So thank you very much.
Thank you, Tim. I have a quick question here that might be answered throughout the conference later on as well. But what kind of testing tools out of the box Kubernetes provide for developer? The main concern is I test the deployed container for security, for feature completeness. And would you be able to give any details on the testing tools out of the box?
So I don't know Kubernetes specifically. Clearly, there's a different way in testing in these environments. So a lot of people may have parallel systems which they initially start off with development, but then pretty quickly get into A/B testing. The ability to route specific proportions of workload onto new type versions of the application and get some very quick feedback. So there's actually a lot more opportunity, I think, here to roll out new capabilities using some real data, some real users. And there's lots of good examples of people in large companies who have that kind of development model of redirecting proportions of their workload out to new versions of the application, seeing what the impact is, both in terms of performance and most function as well.
Okay, Tim. So I think we're going to end this broadcast because we're moving on to World Alliance sessions, and he will talk a little bit more about specifically to Jakarta EE. Once again, thank you, Tim. And once again, thanks everyone for dialing in. We have a very exciting day ahead of us. So hang in there, and we will pull you into another session or go to the session 2. Thank you so much once again. Bye, Will. Bye, Tim. Sorry.
Okay, bye-bye.
Welcome, Will.